In 2025, something extraordinary happened. Not in a laboratory, not on Earth, but far beyond the thin blue atmosphere that protects our world. NASA released a collection of 25 space images that did more than just showcase beauty. These images rewrote our understanding of the universe, challenged long-held scientific assumptions, and reminded humanity of how small, and yet how curious, we truly are. Each image was not merely a photograph, but a frozen moment of cosmic history, captured using machines operating millions, sometimes billions, of kilometers away from Earth. This was not just another year of space photography. 2025 became a turning point. NASA's latest generation of space observatories, led by the James Webb Space Telescope, supported by Hubble, Chandra, Perseverance, Europa Clipper, and deep space probes operating beyond the edge of the solar system, worked together like never before. What they revealed was not just more detail, but entirely new cosmic stories hidden in darkness, dust, and time itself. The first image released stunned scientists instantly. It showed a stellar nursery buried deep inside a molecular cloud, something that previous telescopes could never fully penetrate. Thick curtains of cosmic dust had hidden this region for millions of years. But in 2025, infrared vision peeled back that veil, revealing newborn stars igniting like cosmic sparks inside a vast cloud of gas. These stars were not just forming, they were shaping their environment, blasting radiation and sculpting the cloud into towering pillars that stretched for light years. For the first time, astronomers could clearly see how chaos becomes creation. What made this image revolutionary was not only its beauty, but its timing. Scientists realized they were witnessing a phase of star birth that lasts only a few 100,000 years, a blink of an eye on cosmic scales. This meant humanity had captured a rare evolutionary moment, one that helped explain how our own sun may have formed over 4.5 billion years ago. Another image from 2025 shifted humanity's gaze even farther back, almost to the edge of time itself. A deep field observation revealed hundreds of ancient galaxies, each glowing faintly, each existing when the universe was less than a billion years old. Some of these galaxies were larger and more structured than scientists thought possible at such an early stage of cosmic history. This single image raised a disturbing and thrilling question. Did galaxies form faster than our theories predicted? If the answer is yes, then our understanding of dark matter, gravity, and cosmic evolution may need serious revision. In just one frame, decades of models were suddenly under pressure. But the most emotionally powerful images of 2025 didn't come from distant galaxies. They came from closer neighbors, worlds within our own solar system that had long been dismissed as lifeless. One image, captured during a flyby mission, showed Europa, Jupiter's icy moon, with surface fractures glowing faintly in false color. Beneath that ice lies a vast, global ocean, more water than all of Earth's oceans combined. The 2025 imagery revealed subtle surface changes, suggesting that the ocean below might be actively interacting with the surface. In other words, Europa may not be a frozen, dead world, it may be alive with motion, chemistry, and possibly even biology. For scientists searching for life beyond Earth, this image was nothing short of electric. Meanwhile, Mars delivered one of the most haunting images of the year. The Perseverance rover photographed an ancient river delta from ground level, showing layered sediment structures that could only have formed in flowing water. The textures, angles, and mineral composition told a silent story of a planet that once had lakes, rivers, and possibly habitable environments for millions of years. This was not speculation anymore. This was geological evidence, written in stone. As NASA released these images one by one, a pattern became impossible to ignore. The universe was not just stranger than we imagined, it was more active, more dynamic, and more alive than expected. Black holes were seen tearing apart stars in violent tidal events. Supernova remnants glowed with complex chemical signatures, revealing how the elements that make up our bodies, carbon, oxygen, iron, were forged in stellar explosions long before Earth existed. One image showed the aftermath of a star's death, its shockwaves expanding through space like ripples in a cosmic ocean. Another captured a perfectly aligned gravitational lens, where the gravity of a massive galaxy bent light from a more distant object into a glowing ring. Einstein predicted this effect over a century ago, but in 2025, it appeared with a clarity so sharp it looked almost artificial. But it was real, painstakingly real. Behind every image was years of engineering, decades of theory, and thousands of people working silently so humanity could glimpse the universe's secrets. These were not just NASA's images. They were humanity's images, proof of what happens when curiosity refuses to stop at the edge of the sky. And this was only the beginning. The first part of NASA's 25 jaw-dropping images didn't just show us space. They showed us time, origins, violence, beauty, and possibility, all captured in photons that traveled billions of years just to reach our detectors in 2025. By the time NASA released the second set of images in 2025, scientists already knew something unusual was happening. These were not just updates or refinements of what humanity had seen before. These images revealed processes in motion, cosmic events so violent, so energetic, that they shape the destiny of entire galaxies. Where Part 1 focused on origins and ancient light, Part 2 plunged directly into the raw mechanics of the universe: destruction, transformation, and rebirth. One image instantly dominated scientific discussion across the world. It showed a supernova remnant with unprecedented clarity, a massive star that had ended its life in a colossal explosion thousands of years ago. Previous images of such remnants showed glowing clouds and expanding shells, but the 2025 release revealed something deeper: complex shock fronts colliding with surrounding interstellar material, creating turbulent waves of energy that rippled outward like a cosmic earthquake. Embedded within the debris were unmistakable signatures of heavy elements: iron, nickel, silicon, the very materials that would one day become planets, oceans, and living organisms. This image made something undeniable. Every atom in your body passed through a dying star. NASA scientists described the image not as a snapshot, but as a chemical map of creation. For the first time, they could trace how explosive forces distribute elements unevenly across space, explaining why some regions of the galaxy are rich in planet-forming material while others remain barren. It was violent, beautiful, and deeply personal all at once. Another image from 2025 pushed humanity's curiosity in a different direction, toward worlds orbiting stars far beyond our solar system. Using the James Webb Space Telescope, NASA released the most detailed image ever taken of an exoplanet atmosphere. This was not just a dot or a shadow passing in front of a star. This image contained data, spectral fingerprints revealing gases swirling in an alien sky hundreds of light years away. The atmosphere showed clear signs of water vapor, traces of carbon compounds, and temperature gradients suggesting complex weather systems, clouds, winds, possibly storms. For the first time, scientists weren't just asking whether exoplanets existed. They were asking what it might feel like to stand beneath an alien sky. The implications were staggering. If atmospheres like this were common, then Earth was no longer a cosmic miracle. It was one of many possible outcomes. But not all alien worlds were gentle. Another image revealed a hot Jupiter, a gas giant orbiting dangerously close to its star. The image showed its atmosphere being actively stripped away by stellar radiation, forming a glowing tail stretching millions of kilometers into space. This was planetary death in real time, a reminder that space is not a peaceful place, and survival depends on fragile balances of distance, gravity, and time. Then came one of the darkest images NASA released in 2025, literally and scientifically. A high-resolution view of a supermassive black hole's feeding event showed streams of glowing gas spiraling inward at near light speed. The image captured distortions caused by extreme gravity, bending light into arcs and rings that defied intuition. This was not an artist's impression. This was real data, processed into visible form. What shocked scientists was the scale of energy involved. The black hole wasn't just consuming matter. It was ejecting colossal jets of radiation thousands of light years into surrounding space, regulating star formation across its host galaxy. Black holes were no longer seen as cosmic monsters lurking in darkness. They were architects of galactic evolution. Closer to home, NASA released images that forced humanity to rethink its own solar system. One image of Saturn's moon Enceladus showed geysers of water ice erupting from beneath its surface, illuminated by sunlight like frozen fireworks. Chemical analysis revealed organic molecules, complex carbon structures that, on Earth, are associated with biological processes. The moon was not frozen solid. It was active, dynamic, possibly habitable. Another image of Titan, Saturn's largest moon, showed river channels carved by liquid methane, flowing into vast hydrocarbon seas beneath an orange haze. It was a world eerily familiar yet utterly alien, a reminder that life, if it exists elsewhere, may not look anything like life on Earth. Mars returned to the spotlight as well. A wide-angle mosaic captured ancient shorelines etched into the Martian surface, revealing evidence of long-lasting bodies of water. These were not short-lived floods. They were stable environments, places where chemistry could evolve slowly, patiently, toward complexity. The image felt less like a scientific dataset and more like a message from a lost world, whispering, "I was once alive with possibility." One of the most surprising releases in 2025 came from deep space probes nearing the edge of the solar system. An image of the heliosphere, the vast bubble created by the sun's magnetic influence, showed its interaction with interstellar space in stunning detail. The boundary was not smooth or symmetrical. It was turbulent, distorted, shaped by unseen forces beyond our star. Even our sun, it seemed, was not isolated. It was part of a larger cosmic ocean. As these images circulated, something profound happened. The public stopped seeing space as distant and abstract. It became physical, active, and connected to human existence. Schools, universities, and research centers used these images not just to teach astronomy, but to explain chemistry, biology, and even philosophy. Because when you look at exploding stars and alien skies, you're not just learning about space, you're learning about where you came from. By the end of part 2, one truth had become impossible to ignore: the universe is not static. It is constantly transforming, driven by forces that destroy and create in equal measure. And humanity, through NASA's instruments, was finally learning to read those forces, not as myths, but as measurable, observable reality. And yet, the most shocking images of 2025 were still to come. By the time NASA revealed the third phase of its 25 jaw-dropping space images in 2025, scientists were no longer simply impressed. They were unsettled. These images did not just answer questions, they created new ones, exposing phenomena that challenged long-standing models of how the universe should behave. If part 1 was about origins and part 2 about violence and transformation, then part 3 was about mystery, the uncomfortable realization that even with humanity's most powerful instruments, the cosmos still refuses to fully explain itself. One of the most discussed images of 2025 showed a region of deep space where matter appeared to be missing. Not dark, not obscured, simply absent. Using gravitational mapping techniques, NASA scientists observed how light from distant galaxies bent around an invisible structure. But unlike typical dark matter halos, this region displayed an unexpected geometry. The gravitational influence was present, yet the distribution did not match any known model. It was neither spherical nor filamentary in the way cosmic web theory predicts. This image forced researchers to confront a difficult possibility: our understanding of dark matter may be incomplete, or wrong. The image wasn't dramatic in color or brightness, but it was terrifying in implication. Entire frameworks of cosmology depend on the behavior of dark matter. And here was evidence, frozen in light, that something fundamental was missing from the equations. Another image that dominated discussion came from a prolonged observation of a distant neutron star system. Neutron stars are already among the most extreme objects in the universe, remnants of massive stars crushed into spheres no larger than a city, yet heavier than the sun. But this particular image revealed rhythmic pulses of energy that suddenly changed pattern, as if the star had glitched. The emissions shifted in a way that defied current models of stellar interiors. This wasn't just a curiosity. It hinted at exotic states of matter, perhaps quark matter or unknown subatomic phases, existing at densities impossible to replicate on Earth. For physicists, this image was a doorway into new physics, waiting just beyond the limits of human experimentation. NASA's instruments also captured something far subtler, yet deeply unsettling: a long-exposure image of intergalactic space that revealed faint, ghostly filaments connecting distant galaxies. These structures were predicted by simulations, but never observed with such clarity. They glowed faintly due to heated gas stretching across millions of light years, forming the cosmic web, the hidden scaffolding of the universe. What stunned researchers was the density variation within these filaments. Some were richer in matter than expected, while others appeared starved, suggesting unknown forces shaping the large-scale structure of the cosmos. The universe was not growing evenly. It was lopsided, shaped by influences we barely understood. Closer to Earth, NASA released images that unsettled planetary scientists. One sequence showed subtle changes in Venus's cloud patterns over time, revealing chemical processes still active in the planet's atmosphere. Venus had long been considered geologically quiet, a cautionary tale of runaway greenhouse effect. But the images suggested something else: ongoing atmospheric chemistry, possibly driven by volcanic activity beneath the clouds. This reignited debates about whether Venus might still be geologically alive, and whether it once had conditions suitable for life. Perhaps the most controversial images of 2025 involved fast radio bursts, mysterious signals that originate far beyond our galaxy. NASA's collaboration with international observatories allowed scientists to pinpoint the source of several bursts with unprecedented accuracy. One image overlay showed a burst emerging from a region that appeared ordinary. No massive black hole, no violent star formation, just a quiet galactic neighborhood. This raised an uncomfortable truth. The most powerful signals in the universe may come from places we least expect. Speculation surged. While scientists were careful to avoid sensational claims, the data forced them to admit something humbling: we do not yet understand what powers these bursts. Magnetars were one possibility, but the environment didn't fully match known cases. The universe, it seemed, was whispering secrets in a language we hadn't learned yet. Another haunting image came from a deep space time-lapse showing a star slowly dimming in irregular patterns. Unlike normal variable stars, this one showed no consistent rhythm. The light faded and returned unpredictably, as if something massive was passing in front of it, but no debris disk or planetary system could fully explain the behavior. This image revived memories of earlier anomalies that once sparked wild speculation. But in 2025, NASA's approach was measured and rigorous. The image wasn't proof of anything extraordinary, but it was proof that nature still has tricks left. Even our understanding of time itself came under scrutiny. A high-precision observation of gravitational waves, translated into visual data, showed ripples in spacetime passing through regions previously thought to be relatively calm. The sources were distant mergers of massive objects, but the wave behavior suggested interactions with intervening matter that subtly altered their structure. Time and space were not just passive stages. They were active participants. As these images circulated, scientists felt a shift in tone across the community. The excitement was no longer just about discovery, it was about humility. Every answer uncovered deeper questions. Every image peeled back a layer, revealing not clarity, but complexity. The public felt it too. These weren't just pretty pictures. They were evidence of mystery. Proof that despite all progress, the universe remains vast, strange, and partially unknowable. And instead of discouraging exploration, that realization fueled it. Because if the universe still holds secrets, then exploration still matters. When NASA released the final set of its 25 jaw-dropping space images in 2025, it was immediately clear that these were not just scientific records. They were messages from the future. Where earlier images explored origins, violence, and mystery, this final chapter focused on something far more personal: human destiny. These images asked a question that no telescope had ever asked before. What comes next for us? One of the most powerful images of 2025 showed Earth from deep space, not as a bright, detailed world, but as a fragile, pale sphere suspended in darkness. The image was taken from far beyond the orbit of Mars, where Earth appeared smaller than a single pixel. Yet that tiny dot contained every ocean, every city, every life that had ever existed. The image was not new in concept, but in timing. In an era of rapid technological expansion and environmental uncertainty, this photograph felt like a mirror held up to humanity itself. It was a reminder that Earth is not just our home, it is our only lifeboat, at least for now. Another image signaled a future where humanity might no longer be confined to that single world. NASA released the most detailed orbital image ever, captured of the Moon's south pole, revealing permanently shadowed craters rich in water ice. These were not just scientific curiosities. They were resources, fuel, life support, and the foundation of long-term human presence beyond Earth. For the first time, the moon was no longer seen as a destination. It was seen as an outpost. Mars once again dominated public attention with images that felt almost unsettling in their realism. High-resolution panoramas showed dust storms forming on the horizon, sunlight reflecting off ancient rock formations, and rover tracks slowly fading into the red soil. These were not alien landscapes anymore. They were familiar, almost inviting. Scientists emphasized that these images were more than exploration, they were reconnaissance for future human missions. Mars was no longer a question of if. It was becoming a question of when. Perhaps the most emotionally charged image of the year showed the Sun, not as a steady yellow disk, but as a violent, dynamic star. A massive solar eruption was captured in exquisite detail, with magnetic loops twisting and snapping like cosmic lightning. The image revealed how closely life on Earth is tied to solar behavior, and how future space exploration must learn to coexist with stellar forces far more powerful than anything humanity can control. Understanding the Sun, the image suggested, was not optional. It was a matter of survival. NASA also released images pointing toward destinations far beyond Mars. A detailed view of a near-Earth asteroid showed a surface rich in metals and complex geology. These were not just rocks. They were time capsules, preserving material from the earliest days of the solar system. For future explorers, they represented both opportunity and risk, potential resources, but also reminders of cosmic impacts that once reshaped Earth itself. Another image focused on the outer solar system, showing faint sunlight reflecting off the icy surface of a distant Kuiper Belt object. This was the frontier, cold, dark, and untouched. Yet even here, NASA's instruments revealed surprising complexity, layered surfaces, chemical variation, and signs of ancient collisions. The solar system, it turned out, had no true edge, only gradients of mystery. The final images of 2025 turned outward again, beyond the Milky Way, to galaxies forming new stars at staggering rates. These images were not just scientific triumphs. They were promises. They suggested that the universe will continue creating new worlds long after humanity is gone, or perhaps, long after humanity has spread among the stars. And then came the final image. It was not dramatic. It was not explosive. It was quiet, a deep field image showing empty space, black, vast, seemingly nothing. But hidden within that darkness were thousands of galaxies, each containing billions of stars, each potentially hosting worlds no one had ever imagined. The image made one truth unavoidable: the universe is not running out of places to explore. The only question is whether humanity will keep choosing curiosity over fear. NASA's 25 images of 2025 were not just a celebration of technology. They were a record of human ambition, patience, and imagination. They showed where we came from, how the universe works, what we don't yet understand, and where we might go next. They were proof that even in a chaotic, uncertain world, humanity still looks up, and still dares to ask the biggest questions of all. Because space is not just out there. It is where our future is waiting.